Hello everybody. This is lesson 8. We're moving right along. We just have two more lessons, lesson 8 and lesson 9. This one is about statistics, as you can see. Don't freak out. We don't do high-level statistics in this class. I always tell my method students it's a really good idea to do that, but it should be done in a statistics class. And I do encourage you all to take at least one stats class before you're done at UNA, if possible. But we're going to do some introductory stuff here because I think it's important, even in a research methods class, to at least introduce some of these ideas. So we'll go through this really quickly. Descriptive statistics are really the most basic kind of statistics. You're all familiar with them. These are descriptive statistics that basically condense data sets to allow for easier interpretation. They basically make large distributions easier for us to understand, if that makes sense. So, for example, and a distribution is just a collection of numbers or a collection of scores. So like when you guys took your midterm exam, I had a bunch of numbers, all of your scores were right there, 84, 78, 91, 68, 94, all these numbers. And it doesn't make any sense, especially if it's a large number of numbers, right? If it's a big distribution, like if you were to ask 1,000 people what their age is, that's a pretty big distribution. 1,000, 1,000 scores, right? 1,000 numbers. And if you're just looking at it, it's not going to make any sense to you at all. It's just a bunch of numbers, right? So what you should do is you should turn at that point to descriptive statistics, which help you organize the data in a meaningful way. So the best example probably of a descriptive statistic is the mean or the average, right? And it tells you, obviously, it's a measure of central tendency. So it kind of tells you where the middle is, and that's useful. It's not the end all be all, but it's important. Frequencies are important. That tells you how many times a particular score appears in a particular distribution. So anyways, and we'll look at medians and modes on the next slide. But the important thing here is to understand the importance of the descriptive statistic. Without it, we're kind of just lost. We're just staring at a bunch of numbers that don't really make any sense. And like I said, probably the most common kind of descriptive statistic is the measure of central tendency, and the most common measure of central tendency that you'll see is the mean or the average. But there's also the median, which is the middle score, and there's also the mode, which is the score that occurs most frequently. So try to think, why is the mean not sufficient? Sometimes it's great. But let's take an example. Let's take an exam, and this actually happened in my the other class that I'm teaching right now. I gave the students an exam, and it's a small number of students in the class. I think there are like 11 students in the class, and so one score can really bring the mean, the average, down. And so you're not really getting a good, or bring the average up. And in that case, if that happens, you're not really getting a good idea for what the central tendency is. So on this exam that I gave the students a few weeks ago, everybody was scoring in the 80s, and there were even a couple of 90s, right? Maybe one or two in the high 70s. But I looked at it, I was like, wow, they did a pretty good job. I mean, the average, just based on all of those scores, was like an 83 or something like that. But there was one student, clearly someone who didn't study, who got like a 20 or something like that. And so now, if you get a 20, and there are only 11 students, that brings the average way down. So I thought about that, and I didn't, what I did for this, when I emailed the students, I told them, I said, the average score when removing outlying scores was, and I gave them the average based on basically every score but that one score that was really, really low, right? Because it would have been misleading if I would have included it. So the mean is not always the best measure of central tendency, even though it's the most common. The median is very useful in cases like this because it tells you exactly what the middle score is. This is why, if you pay attention to the news, when they talk about the amount of money, typically, that an American family makes in a year, what do they talk about? They talk about median income. They don't talk about the mean income. The reason, and it's just the opposite in this case, because you have a bunch of people in this country who are ridiculously wealthy, right? Like billionaires, right? You have, I don't know how many there are, several hundred or whatever people that are just multi-billionaires. So if you actually calculated the mean income for an American family, it would be high, relatively high, because those billionaires bring the score up. But that would be misleading, because average Joes don't make a lot of money, right? They make 40, 50, maybe 60K, sometimes less, 30K, whatever, a year. Sometimes less, right? So the better thing to do in that case is to quote the median. And that's why they say the median income. I think the median income in the state of Alabama, because I looked it up when I was moving to Alabama, is like, the median household income is like $43,000 or something like that. Now that's not the mean income, that's the median income. And the mode is just the score that occurs most frequently. Sometimes it's useful to look at that to say, okay, well, boy, I gave the students an exam. 11 people out of 40 scored an 89. That just gives you an idea where a big number are hovering, like where a lot of the students are located on the distribution, right? So that's also a useful measure of central tendency. But we do not want to simply look at the measure of central tendency. It's not enough. When we want to describe a distribution, when we want to understand a distribution, we've got to do more than just look at measures of central tendency. We should also look at to what extent the scores on a distribution are dispersed. We need to look at measures of dispersion, right? And a prominent way to measure dispersion is the variance, and that just tells you how spread apart, how dispersed the numbers are on a distribution are. And you can just look at these two examples. Look at those for a second and let those kind of sink in. What do you notice? What do you notice that's different about those two distributions? In both cases, that's interesting, right? The average, the mean, is 5.0. You could pretend that these are scores on a quiz and that there are 10 students in each, section or in each class. The average is 5 in both. But the measures of dispersion are quite different, aren't they? In the one on the top, very little dispersion. The numbers aren't spread apart. They're not spread out at all. They range from 4 to 6. Everyone either got a 4, a 5, or a 6. And half of the people got a 5. Right? In the other distribution, there's a tremendous dispersion, isn't there? You have a bunch of people, 3 people scoring 0. And then other people scoring 9. 3 people scoring 9. You have some 8s and a 4 and a 3. So you have a range from 0 to 9. That's a lot of dispersion. So those two distributions are not the same. If you only looked at the mean, right, then that would be misleading. So you should also look at the measure of dispersion. This is very important in statistics. And like I said, the variance is very common. It's a mathematical index of the degree to which scores deviate or are at variance with the mean. So in this example, the one on top has a very low variance. The one on the bottom has a high variance, right? A large variance, right? Small variances on large variances is what we're talking in terms of here. The variance is useful. There's a problem, though. And you don't have to understand why, or, I mean, this is all, it's statistics, complex. It just has to do with the formula. But when the variance is calculated, it gives you a result that is squared. It squares the result. And we don't like dealing with squares. Like, I'm not going to tell you, like when somebody says, like, well, how old are you? Oh, I'm 7 squared, or I'm 6 squared. We don't do that, obviously, right? You take, you don't want to deal with squares. And so what do you do, and if you remember back to your basic math classes, to get rid of a result that is squared, what do? You take the square root. Remember the square root? You guys probably took math more recently than I did. I haven't taken a math class in many, many years. But I do remember that much. And so what we do with the variance is we just take the square root of the variance. And then we use that number. And that number is called the standard deviation. The standard deviation. So I want you to know the standard deviation. That's what you're looking for. But I also want you to know that the standard deviation is simply the square root of the variance. Okay? And this is the most common measure of dispersion that's used in research. And you'll see this referenced, in fact, in some of your studies that you've done reviews on for your article review assignment. Some of you have talked about the standard deviation. I don't know if you understood what it meant, but you discussed it, or you reported it. The standard deviation is very important, and here's why. Consider this example. Well, before I tell you the example, take a look at that curve. Everybody remember what that curve is called? It's called the bell curve because it looks like a bell. It's also called the normal distribution. The normal distribution. And this is just remarkable that some things in nature, and when you plot scores on a distribution, a lot of things in life end up being what we call normally distributed. In other words, if you were to start to plot out the numbers, this is what they would look like. They would look like, you would end up getting a curve like that. You'd end up getting a bell curve, right? Which just means a lot of people are in the middle, right? They're very close to the mean, and then you have outliers, right? You have people that are sort of on the outer edges, and then you have a few people that are way out far from the mean, or a few. I shouldn't say people, but just scores, whatever it is. You could, if you looked at the IQ scores of Americans, that's what you'd find. Normal distribution. If you look at weather, average temperatures, and things like that, it ends up being normally distributed. If you look at height is a good example. Weight of people, the average weight, that's another example. So here's the example that I want you to consider, and pay attention because this becomes important, particularly on your exam, on your final exam, because there'll be at least one question related to this, okay? So in the United States, the average height for a man is 70 inches. 70 inches is the average height for a man, 5'10", right? I'm actually 5'10", so I'm right on average. Actually, technically, I'm 5'9 3/4", but I just say I'm 5'10". And with my shoes on, I'm 5'11". So sometimes I'll even mislead people and say I'm 5'11". But that's neither here nor there. So now, this is the important part. The standard deviation, this is real, by the way. I'm not making this up. These are real statistics. The average height is 70 inches. The standard deviation is 3 inches. What does that mean? Now we have to go back to the normal distribution, this bell curve that you see right there. So pay attention. You see a bunch of lines, right? I can't point to this. I wish I had a board, but I'm going to try to explain it the best I can. You see where it says 34% and then another 34% and there's a line in between? The line that's going straight down the middle? That is the mean. That is the mean. So if we were to plot this out, and you might want to do this. I mean, it wouldn't be a bad idea for you right now to pause this, go grab a pen and a paper, okay? And what you should do is draw this out exactly like it looks right here. 34%, 34%, 13.6, 13%, with all the lines, right? Draw the little curve, draw the lines, right? Each one of those lines represents a standard deviation, right? So the first thing that you should do is write the number 70 right on that line, like right at the bottom here, right? Where that, you see where it says 34% and 34%, and there's a line down the middle? That's the mean, which in this case is 70 inches in this example. So you would write a little 70 right on that line, okay? What this is telling you is that, and pay attention, 34% of men are within one standard deviation to the right of the mean or above the mean. Okay? Do you see how there's another, so there's a line in the middle, that's the mean, and then it says to the right now, it says 34%, and then there's another line. So there's two lines there. In between there, that represents 34% of the people, of the scores, in this case, which are men, the height of men, but that little box is one standard deviation. So each one of those little boxes is on this curve is a standard deviation. So you have a total of 1, 2, 3, 4, 5, 6, wait, 1, 2, 3, 4, 8 boxes. So you've got one way over to the left, that's all white. You see that? That little tiny one. Then you got another one that says 2.15%. That's orange. So these are all separate. These are standard. These are one standard deviation. From that 13.6, that's a standard deviation. The 34%, that's a standard deviation. From the mean to the other 34%, that's a standard deviation. So again, let me go back. 34% of men are within one standard deviation to the right of the mean. That means above the mean. They're within one standard deviation to the right of the mean. And 34%, pay attention, and 34% of men are within one standard deviation to the left of the mean, below the mean. So that means, if you can do the math, a total of 68% of men, 34 plus 34, 68% of men are within one standard deviation either to the right or to the left of the mean. What does that mean in practical terms? It means that 68% of the men are relatively close to the average height of 70 inches. Okay? What does that mean in more concrete terms? Well, notice, I've given you here, in this example, the standard deviation. It's 3 inches. So each one of these little boxes is 3 inches. So now let me go. Now, knowing that, what you should be able to do now, remember I said to write a 70 right in the middle, and see that line that's right in the middle between the two 34%? That's a 70. The next line over to the right, you should write a 73. Because it's 3, the standard deviation is 3 inches. 70 plus 3 is 73. The next one over, you should write 76. The next one over, 79. And then let's go to the left side of the curve. You get 70s in the middle, right? We already agreed on 70 is your mean. To that one line over, that's going to be a 67. And then the other line over, that's going to be 64. And the other line over is going to be a 61. Okay? So, what that means now in concrete terms is that 68% of men in the United States are between 67 inches and 73 inches. 5'7" and 5'7" and 6'1". Okay? Let's go out even further. Let's look at that 13.6. Those two boxes. Now we're out to, on either side of the mean, we're out to 2 standard deviations. 2 standard deviations to the right and 2 standard deviations to the left. So now if you add up all of these numbers, if you add up 34 and 34, that's 68. And then if you add another, that's about 27%, right? You're at 95%, approximately. So now you can say that 95% of men are within 2 standard deviations of the mean height for men in the United States. Or in more concrete terms, 95% of men are between 64 inches and 76 inches, which is, let me see if I can do the math, 5'4" and 6'4", if my math is right on that. Okay? So you see where I'm going. And then you can go out even further, 99%, right, would be between 3 standard deviations, right? So now on the test, I might ask you something like, I might give you a similar example. I mean, it won't be the same example, but something similar. And I might say to you, like something like this. What percentage of men are taller than 67 inches? See if you can answer that. Pause it and see if you can answer that. What percentage of men in the United States are taller than 67 inches? Well, the correct answer should be, we know that, okay, in the mean, right, we know that there's the mean down the middle. 50%, it's a normal distribution. So 50% of the men are above the mean and 50% of the men are below the mean. We know that automatically. So if I'm asking you what percentage of men are taller than 67 inches or taller, then we know that we have to go what? 1 box over, 1 standard deviation to the left of the mean, and we're going to add up all of the rest of the numbers. So you're going to add up the 34, the other 34, the 13.6, and the 2.15. Plus, technically, you would add on another 0.5%, because those little white boxes there, that's a total of 1%. There's like a 0.5% over here and a 0.5% over here. So the really, really tall dudes, like the guys that play in the NBA, the 7-footers, they're in that little white box down there. They're super tall, right? That's like, what did I say, 79? Those are the people that are taller than 79 inches, which is 79 inches is, let's see, 6'1", 6'4", 6'7". So there's only a 0.5% of American men are taller than 6'7". Okay. But so in this example, just add up the 50 plus and add 34. So 84% of men in the United States are at least 67 inches tall. If you don't understand that example, rewind this, start plugging in the numbers. I recommend that you do your own examples. And then if you have questions, do a little bit of reading in your book, independent reading. But then obviously if you have a question, if it's not clear, hit me up and we can talk about it on Skype. The z-score, I don't obsess about this, but the standard deviation is the unit of measurement of the z-score. The z-score basically corresponds to the standard deviation, and it tells us how many standard deviations a measure is away from the mean. So this just shows it to you. You can see the standard deviation corresponds to the z-score. So 1 standard deviation above the mean, that +1, the z-score is a 1. Right? Or it could, if the standard deviation is 3, then the z-score is a 3. I just want you to be aware of that. I'm not going to ask you about that on the test or anything. Now, here's where it gets a little bit slightly higher level. I want you to know what statistical test to do in a given situation. Remember what we said. When we're sampling, when we don't take a census, when we're taking a sample, we've got to, and we want to find out if 2 numbers are different from one another. What do we have to do? We have to test for statistical significance. Do you remember that? And we're always going to be looking for what? The p-value. And if it's 0.05 or less, that means there's a statistically significant difference. But how do we get the p-value? We have to do a statistical significance test. And there are many different kinds of tests. And I want to teach you a few right now really quickly so that you know what test to use, at least in some cases. And it's based on, basically it's based on what kind of data you are working with for your independent variable and your dependent variable. But I'm going to stop here for a minute and I'll pick this up in part 2.